In a world still reeling from COVID-19, a more disturbing pattern has emerged that transcends any single pandemic. Join us as we explore the alarming increase in zoonotic diseases, pathogens jumping from animals to humans, and how climate change, habitat destruction, and human activity are creating perfect conditions for the next global outbreak. This isn't just about one virus, it's about a fundamental shift in our relationship with the natural world that could define the future of human health. The shadow of COVID-19 continues to loom large over global health, but scientists are now warning of something far more systemic. Zoonotic diseases, those that jump from animals to humans, are increasing at an unprecedented rate. Recent research published in Nature Climate Change presents a truly alarming forecast. By 2070, climate change will force over 3,000 mammal species to relocate to new geographic regions. This mass migration could create more than 300,000 first-time encounters between previously separated species. Each of these encounters represents a potential viral transmission opportunity, a chance for pathogens to find new hosts and potentially make the leap to humans. The World Health Organization has already documented a 63% increase in zoonotic disease outbreaks in Africa between 2012 and 2022, with similar patterns emerging across other continents. SARS-CoV-2 is just one high-profile example in a disturbing trend that includes Ebola, Zika, and numerous emerging influenza strains. As human and animal worlds increasingly collide, we're creating conditions where these spillover events may become the new normal. The process by which a virus jumps from animals to humans is both complex and frighteningly efficient. When viruses encounter new host species, they undergo rapid evolutionary adaptation. Research from the University of Edinburgh has revealed that sometimes just a few genetic mutations can enable viruses to overcome species barriers. This genetic plasticity allows pathogens to exploit new ecological niches created by environmental change. Consider this: a 2023 study in Science Advances found that climate warming has extended the transmission season for vector-borne diseases by an average of 28 days annually in temperate regions. That's nearly a full month of additional time for mosquitoes, ticks, and other vectors to spread disease. These extra days provide more opportunities for pathogens to establish themselves in human populations and adapt to our immune systems. The consequences extend beyond direct human health impacts. Agricultural systems face mounting pressure from emerging animal diseases that threaten food security. The African swine fever outbreak that began in 2018 resulted in the culling of over 100 million pigs in China alone, demonstrating how zoonotic and animal-specific diseases can destabilize food systems and economies simultaneously. These interconnected vulnerabilities highlight the need for integrated surveillance systems that monitor disease emergence across species boundaries, treating animal, environmental, and human health as parts of a single system. One of the primary drivers of increased zoonotic spillover is habitat destruction, particularly in biodiversity hotspots like tropical rainforests. A 2023 study in the Proceedings of the National Academy of Sciences established a clear and troubling correlation. Each 10% increase in deforestation corresponds with a 7.5% rise in zoonotic disease outbreaks in nearby communities. The Brazilian Amazon, which lost over 11,000 square kilometers of forest in 2022 alone, exemplifies this dangerous dynamic. As logging, mining, and agricultural expansion fragment previously intact ecosystems, wildlife populations are compressed into smaller areas or forced into human settlements. These artificial contact zones create ideal conditions for pathogen transmission. Animals stressed by habitat loss often experience compromised immune systems, making them more likely to shed viruses at higher rates. Meanwhile, humans moving into newly deforested areas encounter wildlife they would never normally contact. The edge between forest and human settlement becomes a front line for potential disease emergence. This pattern repeats across the globe, from Southeast Asian forests being cleared for palm oil plantations to Central African forests giving way to mining operations. Each tree that falls potentially brings us one step closer to the next pandemic. Compounding the problem of habitat destruction is the global wildlife trade, both legal and illegal. This industry, worth an estimated $23 billion annually, transports approximately 1.5 billion live animals across international borders each year. These animals, stressed by capture and transport, often shed viruses at higher rates than they would in their natural habitats. They're then housed in densely packed markets where multiple species interact in ways that would never occur in nature, creating perfect laboratories for viral exchange and mutation. Recent surveillance at wildlife markets in Southeast Asia detected 16 novel coronaviruses with potential human infectivity in just a 6-month monitoring period. These markets essentially serve as potential ground zeros for future pandemics, bringing together species that would never meet in nature, along with the humans who handle and consume them. The problem extends beyond traditional wet markets. The exotic pet trade introduces potential reservoir species directly into homes worldwide. The 2003 U.S. monkeypox outbreak provides a sobering example of how complex these transmission chains can become. In that case, imported African rodents infected prairie dogs sold as pets, which then transmitted the virus to humans. This outbreak demonstrated how the wildlife trade can create unexpected pathways for diseases to reach new geographic regions and populations. While wildlife markets receive significant attention, industrialized livestock production creates equally concerning pandemic risks. Modern factory farms house thousands of animals in confined spaces, creating ideal conditions for viral mutation and reassortment. This is particularly concerning for influenza viruses, which can readily jump between birds, pigs, and humans. When animals are packed together in unsanitary conditions, pathogens can spread rapidly and evolve more quickly. The widespread use of antibiotics in these settings, often to compensate for crowded conditions rather than to treat specific illnesses, contributes to antimicrobial resistance, creating potential superbugs that could complicate treatment of future outbreaks. The global movement of livestock and animal products further amplifies these risks. Animals or animal products carrying novel pathogens can be transported across continents in a matter of hours, potentially seeding outbreaks far from their origin points. The interconnected nature of global food systems means that a disease emerging in one region's agricultural sector can quickly become a worldwide concern. This creates a troubling paradox. The very systems designed to feed our growing population may also be increasing our vulnerability to pandemic disease. In response to these escalating threats, scientists are deploying increasingly sophisticated technologies to predict and prevent future pandemics. The PREDICT program, funded by USAID, has already identified over 1,200 viruses with zoonotic potential since its inception, including more than 160 novel coronaviruses. This initiative uses AI algorithms to analyze patterns in animal behavior, human settlement, and ecological disruption to identify potential hotspots before outbreaks occur. Genomic surveillance has entered a new era of capability and accessibility. The Global Virome Project aims to catalog up to 800,000 unknown viruses in wildlife that could potentially infect humans. Using portable DNA sequencers that can be deployed in remote locations, researchers can now identify novel pathogens within hours rather than days or weeks. This rapid detection potentially allows containment measures to be implemented before widespread transmission occurs. Machine learning models are increasingly able to predict which viruses pose the most significant spillover risk. A 2022 study in Cell demonstrated that neural networks trained on viral protein structures could identify zoonotic potential with 70% accuracy. This technology could allow public health resources to be directed toward the most dangerous pathogens before they make the leap to human populations. Meanwhile, satellite imagery combined with ecological modeling helps identify emerging hotspots where habitat fragmentation and human encroachment create ideal conditions for spillover events, allowing for targeted surveillance and prevention efforts. One of the most promising developments in pandemic prevention is the expansion of wastewater surveillance systems. Initially deployed to track SARS-CoV-2 variants during the COVID-19 pandemic, these systems are now being adapted to monitor for a broader range of emerging pathogens. By sampling municipal wastewater, scientists can detect viral genetic material before clinical cases appear in hospitals. This creates an early warning system that can potentially identify outbreaks days or even weeks before traditional surveillance methods. The power of wastewater surveillance lies in its population-wide coverage and efficiency. Rather than testing individuals one by one, a single wastewater sample can provide information about thousands of people simultaneously. Advanced genomic techniques can identify not just known pathogens but also novel viral sequences that might indicate emerging threats. Cities across the world are now installing permanent wastewater monitoring stations, creating a global network that could serve as a first line of defense against future pandemics. The data from these systems feeds into international databases, allowing for real-time tracking of pathogen spread and evolution. When combined with clinical surveillance and animal monitoring, wastewater testing creates a comprehensive early detection system that spans the human-animal interface. The financial stakes of addressing zoonotic spillover are enormous, making prevention not just a public health imperative but an economic one as well. The COVID-19 pandemic has cost the global economy an estimated $16 trillion in lost output, healthcare expenses, and long-term disability. By contrast, preventive measures would require just a fraction of that amount. The World Bank's newly established Pandemic Fund has secured $1.6 billion in initial funding to strengthen early warning systems and response capabilities in vulnerable regions. However, experts from the Harvard Global Health Institute suggest that truly effective global prevention systems would require annual investments of at least $10 billion, still less than 0.1% of COVID-19's economic impact. These numbers reveal a stark truth: pandemic prevention offers perhaps the highest return on investment of any public health intervention. Yet funding remains woefully inadequate compared to the scale of the threat. The challenge is partly one of human psychology. It's difficult to justify spending on disasters that haven't happened yet, even when the evidence suggests they're increasingly likely. This prevention paradox has hampered efforts to secure adequate funding for surveillance networks, research initiatives, and capacity building in high-risk regions. Breaking this cycle requires reframing pandemic prevention not as an optional expense but as essential infrastructure for global security and economic stability. Policy experts increasingly advocate for a One Health approach, recognizing the fundamental interconnection of human, animal, and environmental health. This framework acknowledges that we cannot address human disease in isolation from the ecological systems in which we exist. The European Union recently committed €5 billion to a One Health action plan that includes stricter regulation of wildlife trade, expanded disease surveillance networks, and habitat conservation initiatives. This represents one of the most significant governmental investments in this integrated approach to health security. China has permanently banned the consumption of wild animals as food and significantly restricted wildlife markets following COVID-19, though enforcement remains challenging in many regions. These policy changes reflect a growing recognition that traditional boundaries between veterinary medicine, human healthcare, and environmental management are increasingly obsolete in a world where diseases regularly cross species barriers. International governance frameworks are evolving to address these challenges. The World Health Organization's pandemic treaty negotiations aim to create binding commitments for pathogen surveillance and response. At the same time, the Convention on Biological Diversity now explicitly recognizes disease regulation as an essential ecosystem service. These developments signal a growing recognition that pandemic prevention requires coordinated global action across multiple sectors, treating ecological health as inseparable from human health. As climate change continues to reshape ecosystems and human expansion further encroaches on wildlife habitats, the threat of zoonotic spillover represents one of our most significant public health challenges of the 21st century. The interconnected nature of this threat, spanning environmental policy, agricultural practices, global trade, and healthcare systems, demands integrated solutions that transcend traditional disciplinary and national boundaries. The question facing humanity is not if another pandemic will emerge, but when, and whether our detection and response systems will be ready when it does. Building resilience against this threat requires sustained investment in surveillance technologies, habitat conservation, and alternative economic models that reduce pressure on wildlife populations. It demands rethinking our food systems, from industrial livestock production to wildlife consumption. Perhaps most importantly, it requires a fundamental shift in how we conceptualize human health, not as separate from ecological systems but as fundamentally dependent on their integrity and balance. Our future security depends on recognizing that the barriers between animal and human diseases are far more permeable than we once believed. Every forest preserved, every wildlife market closed, every surveillance system deployed brings us one step closer to a world where pandemics might become rare rather than inevitable. The path forward requires not just scientific advancement but a profound reconsideration of our place within the natural world. The rising tide of zoonotic diseases represents not just a health crisis but a fundamental challenge to how we understand our relationship with the natural world. As we've explored throughout this journey, the boundaries between human health and ecological systems are far more permeable than our medical and political institutions have traditionally recognized. From the deforested edges of the Amazon to wildlife markets in Southeast Asia, from factory farms to the cutting edge of genomic surveillance, we're witnessing the consequences of treating these systems as separate rather than interconnected. The COVID-19 pandemic may eventually fade into history, but the conditions that spawned it, habitat destruction, climate change, wildlife exploitation, and industrial animal production, continue to accelerate. Our future security depends on addressing these root causes rather than simply responding to each new outbreak as it emerges. The One Health approach, which recognizes the interdependence of human, animal, and environmental well-being, offers a framework for this essential transformation. The financial case for prevention is overwhelming, with the cost of pandemic preparedness representing a fraction of the economic damage from a single global outbreak. Yet perhaps the most profound shift required is philosophical, moving from seeing ourselves as separate from nature to understanding our health as fundamentally embedded within ecological systems. The barriers between species are not as solid as we once believed, and our survival depends on respecting these connections rather than ignoring them. The path forward demands not just scientific innovation but a reimagining of our place within the web of life. Thanks for watching. Please like, subscribe, and hit the bell icon for updates. Your feedback is appreciated. We hope to see you again.